Hey guys, so welcome to the video. We are going to talk about solving quadratic equations. The past week, we've been talking about the general form and understanding really what it means, what other coefficients means. But now it's time to solve the equations. All right, this video is going to feel very content heavy. All right, it's going to feel a bit like I'm throwing a lot at your face, but I promise you, after we go to class on Monday and Tuesday, that's a D block and F block respectively, it will feel like a lot done in such few steps. All right, so buckle up, focus up, and yeah, let's go. So anyway, there are three ways to solve quadratic equations. We got the formula. You can use the quadratic formula, which is what we'll learn today. Then next, we can use factorization, or I'll just say factoring actually. It's by factoring. And lastly, completing the square. Okay, so these are the three ways by which I will teach you how to solve quadratics. And for today, we will begin by using the formula. So to solve quadratic equations, we will have to make a slight addition. We'll alter our general form, all right? So I gave you the general form of a quadratic equation as ax squared plus bx plus c, yeah? Now to solve them, we need to equal this to 0. All right? We need to equal our quadratic, our formula to 0. All right? That's and oftentimes in questions you'll see it as being given to you as ax squared plus bx plus c equals 0. All right? So now, the next step here is to understand, what does this equals 0 even mean? Like, what does this mean graphically for our graph, right? Well, what we're saying here is that I have my function ax squared plus bx plus c equals 0. And I'm going to call this function, I can call it f of x, right? F of x equals to ax squared plus bx plus c. This is true because it's a function of x. I can also call f of x. It has another name, and that name is y. I can call f of x y, and y is going to be ax squared plus bx plus c. All right. So now, my y, I'm going to equate it to 0. Oh, this looks like something we've seen before. All right? So, let me tell you something. The solutions to a quadratic equation are called roots. All right? And these roots are found when y is equal to 0. All right? When y is equal to 0. So, using your background knowledge of what we've done in the class, where do we find these roots? At the x-intercept. All right? And basically, we are solving for the x-intercepts. And the solutions are called roots, and the roots occur at the x-intercept. Another name for roots is zeros, all right? Is zeros. So, yeah. Anyway, let's move on. So to solve our quadratic equation, so now I'm going to teach you the quadratic formula, all right? So to solve our quadratic equations that have a general form of ax squared plus bx plus c equals 0, we can use this general form of the equation, of the solution, all right? So it's minus b, all right? We get the b from there, minus b plus or minus square root b squared minus 4ac over 2a. That's, of course, x is equal to b. So b minus b plus or minus square root b squared minus 4ac over 2a. So these are two. So before I move on, this is the general form of the solution. I know it may seem a bit cryptic, but all you're doing to solve for these quadratics is trying to find. Is just plugging in A, B, and C wherever you see A, B, and C, and then putting it into a calculator and getting your answer. It's not that hard, I promise you. So, and as we can see, here I have a plus or minus. This just tells me that this is actually two equations, all right? So x is going to be equal to minus b plus b squared minus 4ac over 2a. So I can call that x1. So that's my first root. And x2 will be minus b minus b squared minus 4ac over 2a. All right. So how I'd get through this equation is just by plugging in a, b, and c wherever I see a, b, and c, putting it in a calculator and solving. All right, and we will do one example in this video. So, yeah. Anyway, let's move on. So, you might ask yourself, why do I have two roots, or why do I have two equations, right? Two equations, right? Like you saw here, I have x1 and x2. Why do I have two of those? Well, remember, I told you the roots occur at the x-intercept, right? And the x-intercept is where y is equals to 0. And if this is my y and this is my x, this is my y and this is my x-axis, y and x, y equals 0 is this line, all right? This is y equals 0, just in case you guys didn't. I know you guys know this, but I'm just as a review. Y equals 0. This is x equals 0. But this line here is y equals 0. So, the reason I have two equations is because my parabola can cross the x-axis 2 times and thus have two roots. All right? All right? So, so that's why I have two equations. That's why I have two solutions. One with a plus sign, the square root, and one the minus square root. But it's not always the case that I will have two equations. Two answers. There are times when I'm only going to have just one root. All right. So here, one root. Here, two roots. Yeah. By the way, in case you're confused here, the roots are just the x-intercepts, all right? So here I have two x-intercepts, I'm saying two roots, and here I have one x-intercept, I'm saying one root. And there are even times I'll have no roots, all right? No roots. In these cases, my answers will be, my roots will be imaginary, all right? So I'm going to say imaginary roots. All right? When there's no x-intercept, the roots are imaginary, all right? And we won't deal too much with imaginary stuff, imaginary numbers too much. All right. So, anyway, you must be wondering, well, is there a way I can know how many solutions I'll have before even solving the quadratic? There's a way. We can use the discriminant, all right? So here, let's say I write, there is a way we know how many solutions we will have before we solve our quadratic. We use the discriminant. So if my general form, let's see, if my general form is ax squared plus bx plus c, right? My discriminant is going to be given by, the expression b squared minus 4ac. And this is the same discriminant, the same expression that's under the square root sign, right? So this expression here, the b squared minus 4ac, is called a discriminant, all right? So now, when I plug in my a, my b, and my c into the expression, and it evaluates to a positive number, I know that my quadratic, I know that there will be, my quadratic will have two solutions, all right? We'll have two solutions. If b squared minus 4ac evaluates to 0, all right? If my b squared minus 4ac evaluates to 0 after plugging in my a, b, and c, it will have one solution. If b squared minus 4ac evaluates to a negative number, then there will be no real solutions, only imaginary. Okay, so now it's a lot of words I've said towards you guys. I hope you're not too confused. I hope this is somewhat clear. Let's try and solve a problem right now, yeah? So I have x squared plus 6x plus minus 16 equals 0, all right? So how I'd solve this, my first step would be to identify what my a, b, and c are. So here, my a is going to be 1, my b is going to be 6, and my c will be minus 16. And you might ask how a is 1. Well, you know, if there's nothing next to a, well, you can always imagine there's a 1 there, all right? So actually, you don't have to imagine. You can always assume it's there. It's because it's a fact that it's there, all right? So after I identify actually, let me do this. Let me say step one, identify, identify A, B, and C, all right? So if my A is going to be 1, my B 6, and my C is going to be minus 16, right? I now know that. My step 2 will be to just write out the quadratic equation. So I'll say x will be equal to minus b plus or minus square root b squared minus 4ac over 2a. All right? And then at